All right, so today we'll start a new topic called load balancers. So let's see why we use them. What are those exactly? Yeah. So let's imagine a scenario that we have an application. Just as an maybe as an example, Google. Let's say you have an application and you deployed in one server. Okay, obviously, and it's it's being accessible by everyone. It's okay as of now. It's okay, but users are increasing and the traffic is increasing obviously, but one server cannot handle it. It's keep on getting down because of too much load in your system. So you got some idea that okay, I need something, or I need an extra server where I can handle the load. It can handle the load, like let's say one server is there, it's handling all the traffic, let's say thousands of requests or millions of requests, and I got a new server and I want to share the load between the 50-50 percentage. So that will be little better, right? Or let's say two also not enough. I created five servers I want, so that five servers can share the load. Or I need 10 servers will share the load, whatever the incoming load. Or imagine like an application like Google, it's worldwide, right? So obviously it needs thousands of servers because it's accessible every second. It will be accessed every second. There is no downtime for Google. I mean, there is no stopping Google. Correct? I mean, that's a huge application, right? So imagine how many servers it is required to handle the load. But okay, I'll create servers. Okay, maybe 1,000 servers or whatever, 10,000, whatever it is. How we access it? How it works? See, we just open the application using domain name www.google.com. So, but this google.com website, it should point to somewhere, right? If you have 1,000 servers, how, if it is one server, if I request it, it will go to the server. I mean, the domain will forward the request to the server. But now there are 100 servers or 1,000 servers. Now where the request will go? That's where the load balancer comes in. So what happened here is load balancer. It's actually we can say is a system, simply to keep it simple. Load balancer is something where it will be in front of your servers, and whatever the incoming traffic is there, right, that will load balancer will take the traffic and distribute it among the servers evenly. So imagine now, let me show you where yeah, this one. This is one server, 2, 3, 4. Imagine these are the servers. Now here, what is the access point? I mean, I want to access. I'm trying to access my application google.com. Let's say here. Sorry. So I hit google.com. Why the hell is this game? That's okay. User is there. I am the user. I hit google.com. Now, if it is one server, as I told you, it will go to some server wherever it is running. But now there are more than 10, right? How the traffic should flow? So how what happens is the load balancer will actually be in front of your servers, and if the request comes, this load, let's say user hit application domain google.com, let's say the request will come to load balancer, and from load balance to whatever the servers inside the load balancer, they will get the request. So it will try to distribute the traffic, same way, like for all the servers. Let's say two servers 50-50 maybe. Let's say three servers 30-33, something like that. I mean, I'm just trying to say the example. It will try to distribute the traffic evenly for everyone. So the traffic distribution by default we call it round robin method. It means if a request comes, a load balancer will take it and forward the request to the first server. This is the first server, right? If the second request came, load balancer will forward it to the second server. If third one came, load balancer will forward to third server. If fourth one request came, like this, it will send the traffic to each and every server. If a new request came, it will send to new server. And again, let's say the servers are full now. Until here servers are full. Now again it will come back from beginning, like that. Let me write the number for clear understanding. So we have 11 servers overall. Okay, so now let's say I told you, right, each and every request will point to each and every server in the load balancer. Now let's say 11 are full, it will come to first again. Again it will do the same thing. First request to 1 2 3 4, next. Again it will come to first. Depends on how many servers you have. So it will make sure that whatever the traffic is coming to you, load balancer will accept the traffic, because load balancer is a single point of contact now. Because you have 11 servers, what server you will access, how you will access it, you can't, right? There are 11, how you access? So that's why load balancer will act as a single point of contact for you. Out of 11, it is a single load balancer which will act as single point of contact for you, so that your application can access that. I mean, your traffic will go to the load balancer, and load balancer, once it receives the traffic, it will distribute the traffic evenly across all the servers. It will make sure the traffic is distributing to all the servers. It's not like one server will get huge traffic, another server will get less traffic. It's not like that. It will make sure all servers are getting same traffic. I mean, based on their requirement, based on their configuration, I would say. So, and of course, there is one more advantage. Like, let's say server 6 is down for some reason. I don't know why. It's some issue. Now what happens? Load balancer will not send the traffic to this one. So once the traffic comes to server 5, it will send to server 7. It will skip the server 6, because it's not okay. It's not healthy. So load balancer will try to make sure that it will send the traffic only to the servers which are healthy. So if the server is not healthy for some reason, maybe there are multiple reasons, like memory is full or server is crashed. There are multiple reasons, right? So if server is not healthy, load balancer won't send the traffic to you. So that's one of the advantage. We call that fault tolerance. Fault tolerance is something like prevents downtime by rerouting the traffic during server failures. What is this? So that's about load balancer. Got it? So here what happened? What is the advantage we are getting? Our huge traffic is handled by multiple servers now, not just one server, and load balancer is distribution of the traffic. All we have to do is set up the load balancer and add your servers, whatever servers you have, so that let's say I have 5 servers and I created a load balancer. What is the connection between them? There is no connection, obviously, right? So I had to add the servers to the load balancer. Then load balancer knows, okay, there are 5 servers, I need to send the traffic to these 5 servers. Okay, then load balancer will know it. That configuration we need to do. Got it? So that will be seeing now. Coming to AWS, we have already seen the load balancer topic in Kubernetes, but yeah, same thing. So in Kubernetes, load balancer works between the pods, here between the servers. So that's the difference. Remaining all are fine. Even in the Docker, right, we have seen automatic load balancing within the container, between the containers. Same approach. Here also, but between the servers we are doing as of now. That's it. That's the only change. But remaining, The working, how the load balancer works, everything is same. There won't be any change. Got it? Let's see. First, let's create two servers. Before load balancer, we'll create two servers and we'll share the load between them. Okay? Let's test that. I'll create two servers. Some sample I'll just install Nginx. I mean, that's it. Apps simply I'll call it. Number of instances I'll keep 2. I think Amazon Linux is fine for me. This is fine. Key pair. So wait. Okay, I don't have to create new key pair. Something demo something anything whatever it is. Download. Firewall. Load balancer also works on, I mean, there is a load balancer, I'll tell you. They usually work on port numbers and protocols. So one of the load balancer uses HTTP port numbers 80 and 443. So you have to allow them in firewall. So it's already allowed for me, so I'm not doing anything. Let's, oh, I forgot the user data. I forgot to include the user data to install Nginx. Yeah, that's okay. I'll log in manually. What is there? Refresh. It's running. Let's go. Maybe change the name to 1. Apps 1. Let's log in. I'll just install Nginx. That's it, and I'll add some basic content. That's it. Yes. Go to yes AP. Sorry, yum right. Yes, installed systemctl start Nginx. I enabled it. Let's see the status. It's active running. Now let's create a sample file. /HTML. I'm just creating a sample file. I'll keep like this is server 1 just for our example, because when we when we are in load balancer is distribution the traffic, we want to see the output, right? That's why what I'll do is in one server I'll keep a different content, in another server I'll keep a different content, just to show the whether it is distributing the traffic or not. Usually it will be the same thing, but I'm just trying to show you the output. That's it. Now I should be accessible with this IP. 80 not allowed. Let me see. It is allowed, so it should work. Wait 34 to 45 43 103. Yes, it should be running. Let's try here. Okay, in local it's working, not in remote. What the hell? It is allowed. Okay, alright, it's listening. Okay, cool. What the hell is wrong with this? Firewall is allowed, obviously I've just seen it. So it can't be reached. 80. Okay, 0.0c. It's too dark. No. Why? Let's try in server 2. This is server 2. I'm trying to install same thing, Nginx and everything. Let's see. Yes. Let's go. I'm just setting up Nginx. Don't worry about all these things. What are these about? This is server 2, so that the output you can see. Okay, let's see the status. Okay, all good. Let's try accessing locally. Okay, server 2 is coming. Now let's see, is there any file over in local or not? Just no, awesome, all good. There is no firewall, obviously. This is also good. IP table is not there. Now at least this should open. There's some issue somewhere. Is it still 2x2 checks not passed? What has been changed? Nothing. Let me see. Firewall is allowed. All good, all good. What the hell is the issue with this? Oh, sorry. The hell, it's taking HTTPS, the browser. Thank you, Chrome. Yeah, see now. Sorry, my bad. By default, it's taking HTTPS. I don't know why the Chrome is taking like that. Yeah, it's okay. This is one server. See the output, server 1. This is server 2. So see the difference output. Just you can see the difference, right? So what I'm trying to show you is, we'll add these servers into a load balancer. We'll create a load balancer, add these servers. Now we'll see how the load balancer is distributing the traffic. So let's see that. So let's go to load balancers in AWS, obviously. Yes. So we don't have any load balancers. Create a load balancer. If you see, there are 3 load balancers and of course the older one 4. So this is a classic old generation, so we don't usually use this anymore, but of course you need to know it. Let's start with classic load balancer, or you can skip it if you don't want them later. So but now classic load balancer is one of the type, which supports all the protocols, HTTP, HTTPS, you can see here, TCP, SSL protocol, so all it will support. All you have to do is create a load balancer, add your servers, that's it. Let's try it simple, as just create it, give a name. What is the name? Demo load balancer, something demo. So now there are 2 types of load balancers, internet facing and internal. Internet facing means anyone can access outside. Internal means only within the specific network will be accessed. This will be accessible. But of course we want to make it internet facing because we don't have network anything, we haven't seen that. So let's keep it internet. And network mapping, leave the network as it is default, and availability zones, choose all the availability zones. Why? Because you have created 2 servers and the servers may be in a different availability zones. Let's say I forgot to choose 1A, EU West 1A, let's say, imagine, and my server is in here, this 1A availability zone only. It means you can't add your server to load balancer. So if you select here, then only whatever the servers in this availability zone can be added to the load balancer. So it's better to select all the availability zones no matter how many are there. So now security groups, I selected default, mine by default it came. So you can choose whatever you want based on it. And yes, there is something called listeners. This is important one. Listeners is like how the request will be forwarded to your servers, on which protocol, on which port number. See, I told what I told. The request, some guy will, he'll hit our website, and the request will come to our load balancer. Okay, it came to our load balancer. Now from load balancer, the request should go to server, backend servers, whatever we have added into the load balancer, right? So how the request will go from load balancer to server? It has to be through some protocol, through some port, correct? That's where these things comes. So this is listener protocol at the load balancer level, at which port, which protocol you need to use. If you have SSL certificate, choose HTTPS. You have to add SSL certificate here. We haven't done that. Again, we'll see that later point of time, no worries. But for now, just keep it HTTP AT protocol. So load balancer protocol and port is 80, and it will send the traffic to instance to the server protocol 80 or HTTPS if you have it. So load balancer will receive the traffic in 80 port, and using that 80 port it will send the traffic to server. Server also receives the traffic in 80 port on HTTP protocol. That's what we selected. If you want to change it, protocols and port numbers, you can simply change it. But of course HTTPS we need certificate. We don't have it. For now let's keep it HTTP. So that's about listeners. So how the traffic should flow from load balancer to targets. Targets are nothing but instances which are behind the load balancer. That's it. Targets, servers, instances, all are same here. So that's about the listeners. Next we have health check. I told you earlier that load balancer will send the traffic only to healthy instances. I mean, which are healthy, which are fine. How does it know which are fine or which are not fine? Of course, we'll be doing the health check. Correct. The health check you have to add it. So you have to add a health check. What happens is it will do the health check based on your configuration. So we have something called ping protocol, ping port, and ping path. So with this information, it will try to talk to the server. So information means ping protocol, HTTP, port number is 80. By using this port number, it will try to ping whatever the path you give here, /index.html. So it will try to ping this path. If this path exists, if this path accessible, it's healthy. Let's say path does not exist, 404 error, right? So it's not healthy, server is not healthy. Or if for some reason it is not accessible, maybe the Nginx is down in the server, application is not running, so it's unhealthy. So like that it will decide. If you click on advanced, we can set it. How much response time? Maybe 10 seconds. Interval every 10 seconds you ping it. And unhealthy threshold means how many times, if it is not responding, how many times I have to decide whether it is unhealthy or unhealthy. Let's say if it is 2 times as an example. So if 2 times the server is the health check is failed, it means the server is unhealthy. It will remove it automatically from the load balancer. And healthy threshold also same. I'll keep it 2 only by 10. So if healthy server is responding 2 times healthy, I mean inline continuously, it means it's healthy. If it is not responding, it's unhealthy. 2 times only. So it will try to ping these things, and for every 10 seconds it will wait for 10 seconds for the response. If it is response came within 10 seconds, it's healthy. If it is not came, unhealthy. Correct? So if it is 2 times not came, unhealthy. 2 times came continuously, healthy. That's about the health check. You can change your timings according to your scenario. Now here are the final thing. Add instances. You have to select your which servers you want to add. Of course, I have only 2. Let's select those 2. Confirm. Those will be added. See here. See. Got it? Now after adding servers, there is something called attributes. Let's see what are those. So the first thing, let me say this one first. Connection draining. What is connection draining is, let's say my server became unhealthy suddenly. I don't know why. I mean this server, let's say apps 1, my server became unhealthy for some reason. What load balancer will do is, it is doing the health check, right? 2 times it became unavailable, so it is unhealthy. Load balancer will immediately remove the server. Immediately remove it. But imagine at that point of time, now let's say my server is became unhealthy suddenly. At that point of time, it will remove automatically, as I told. At that time, if let's say some user is accessing the application, some user is already using the application, and the request created, the request is currently pointed to that server only. So if suddenly load balancer removes the server, the user will see some issue 404. Not 404, server crash or something. Usually when website is down, we will see some site can't be reached. That error it will show, which is not good, right? So what happens is, I'll repeat again. Let's say I'm trying to access, I'm currently accessing your application, and suddenly your server became unhealthy. Load balancer should remove it automatically. It will remove immediately. So if you remove it immediately, whatever I'm accessing, it will show site can't be reached. So I don't want that. I don't want to do that. If server is unhealthy, wait for a few minutes. What do you mean wait for a few minutes? Is either you give a specific timing, maybe 30 seconds as just example, or you wait until the request, whatever the connections whatever are there to the server are closed or finished. So any of it, whichever comes first. Let's say if 30 seconds comes first, it will wait for 30 seconds and remove the server out of the load balancer. Or if it is, let's say the requests are closed before 30 seconds, it will remove the server immediately. So maximum is 3600 seconds. It means 1 hour. So you can keep the connection, you can keep the server within the load balancer for 1 hour, even if it is down, even if it is unhealthy, which is not a good practice. You don't keep it 1 hour, just maximum 5 minutes or something like that. So for now, just for example, I keep it 30 seconds. We'll test it also, don't worry. So that's about connection draining. So next we have cross zone load balancing. So if you enable this, what happens is, let's say I have two servers are there. So in two servers, one is in availability zone 1A, another is in availability zone 1B. So if what happens generally is, it will send, with this, it will send generally, it will take the request, it distribute the request across all the registered instances. But it won't be evenly. So what happens here is, by default, let's say as I told you, two availability zones and two servers with, I mean, one server in each server, easy. By default, what happens is AWS, let's say, I mean, this load balancer, if it, if you got a request, it will send to one load balancer, sorry, one server I told you, and second request also try to send to the same server. Why? Because the other server is in a different availability zone, so it couldn't understand that. So if you enable this option, cross zone load balancing, it means it will make sure all the servers, even they are in different availability zones, will get the same traffic, will be distributed evenly for all of them. That's where the enable cross zone load balancing will come. So by default they are enabled, I mean, I didn't enable it, right? So it's good to have that. If you don't enable these options, either cross zone load balancing or connection training, so I mean, of course load balancer will work, not fully functional, I would say, because connection training, as I told you, it will remove immediately, which is not a good practice. Same thing, cross zone load balancing, it will distribute the traffic to servers which are in the same availability zone. I'll repeat cross zone load balancing again if you want. So we have, let's say, 4 servers are there. 2 are in one AZ, 2 are in another AZ. So if the traffic come, the load balancer will take the traffic and distribute the traffic in the 2 servers which are in the same availability zone, not in different availability zone. So you have to enable this in order to make sure all the availability zones should get the same traffic. So you have to enable that. That's why it's already enabled. So now these are all we have already review page, I mean, whatever you selected. Let's create a load balancer. Oh, there is something. Interval must be greater than response time. So interval maybe 15 seconds. Let's keep it, 10. Let's keep it maybe 8 seconds. Yeah, and it should be fine. Nginx respond faster only. Load balancer is created. If you select it, it will give you an endpoint for us. There is a DNS name. So with this we can able to access our application. But let's wait before, because sorry, why? Because there is health checks. The health checks will be happening now. I told you, right? 2 times healthy, 2 times unhealthy. It is started now. How do you know whether it's health check started or not? Go to target instances. See, currently 2 instances which I added, right? It is still not yet started, I believe. That's why it is showing out of service. So in health state description, instance registration is in progress. I mean, it's trying to add these servers to the load balancer. Let's wait. It will take some time, obviously, based on our configuration. Unknown. See, it came in service. It means all good, no worries. Now we can access our application. Go to details, domain name, it should work now. Meanwhile, let's see again the health check. Where is this? In service. Yes, it should be good. Oh wait, HTTPS. Sorry, my bad. I don't know why Chrome recently. See, this is server 2. Refresh. Server 2. Server 1. Oh, sorry, server 1. See the request, how the traffic is distributed. I told you, right? That's why I give the different names to show you. See, that's how the traffic is distributed across the servers. If you have 10 servers, of course it will distribute it. We have only 2 servers, so that's why, see like that. Server 2 now, currently its traffic is going to server 2. See, server 1 now, like that it will handle like that. You got it? Now if I stop one server, let me stop Nginx maybe. Obviously 2 sessions are expired. Maybe I'll stop Nginx 2, just for example, Let's see. So now if I stop server 2, the request will go to only server 1. As of now it will go to server 2 also. So now what happens, I'll remove this, I'll stop the nginx in server 2. The health check will first, the health check it will keep on doing, right? The health check will fail, unhealthy, something like that. Let's see, sudo systemctl stop nginx. Sorry, I stopped it. I mean, it's doing it. It stopped. Let's wait for few seconds. Server 2 should be down. Wait for few seconds. Patience. See. Now what is the connection draining period? 30 seconds. It will wait for 30 seconds and the server will be removed automatically. Now try to access. What happens? Try to refresh. No matter what, the traffic will go to only server 1, because I told you, right, load balancer will send the traffic only to healthy instances, not to unhealthy servers. It won't send the traffic to unhealthy servers. See, no matter how much, it will do like that only. And of course it will, 30 seconds should be done by now, not it. So it will remove automatically. It won't care about it anymore because it's unhealthy. Still, yeah, it'll maybe taking some time. So that, but you got my point, what I'm saying. Let's start nginx again. Let's see. Yes, let's wait for, I think 25, 10 seconds I gave, maybe 30 seconds. Let's wait for 30 seconds. Yeah, see, it came back. Let's refresh. See, now traffic came to server 2. See, that's how it works, load balancer. Is it clear? Is it clear about classic load balancer and how the load balancer works? Because there are other types of load balancers also which we'll discuss now. Concept is same, a little changes, but concept overall will be same. So is it clear? Now yeah, let's go to another load balancer type. So you can click on manage instances and remove your instances from load balancer, obviously. Deselect. Yeah, I removed it. Save changes. Now there are no servers. There should be. Why still are there? Deregister. So okay, let me select 2. I'm not deleting the servers. I'm just removing the servers from load balancer because I don't need it. Now you can simply click on actions, delete load balancer, confirm, blah 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 blah, blah, delete. Done. So now let's go to another load balancer type. Create load balancer. As I told you, this classic is old generation, previous generation. People nowadays don't use it. Why? Why they don't use it? Because if you see classic, we're adding the servers. That's it. It's just a very direct, basic approach. But nowadays we have containers. Most people uses containers, right? I want to distribute the traffic to containers. So classic cannot do that. And obviously, let's say nowadays everyone will going to microservice architecture. It means application is divided into smaller parts and they'll deploy them independently. So just like services, different services, but they belongs to same application. You may imagine, like the best example I would say is e-commerce application, Amazon or Flipkart, whatever it is. So they'll maintain them separately, like the login page will be running separately, and the cart page, whatever cart you see, right, that page will be that service will be running separately, and payment gateway service will be running separately, and the feed, whatever you're seeing, the list and everything, that will be running separately. Why they're running separately? Because if they're running independently, if one thing goes down, let's say payment goes down, other things will not be affected. Other things, let's say payment is down for some reason, but in Amazon you can still select the list items and add to cart, right? So that's why. So other functionalities won't affect if you're running in a microservice architecture. It means running the services independently. But if there is another thing, like running as a single application, which is called monolithic. Microservice and monolithic. Earlier we used to have microservices. Sorry, monolithic. Everything will run as a single application. Now people are very much using microservice. That disadvantage with monolithic is, if something goes wrong, the whole application is down. But now in microservice we have divided them into smaller parts. That's why the independence is there, and if something goes wrong with the, let's say, login page, others are not affected. Let's say people are already logged in. Now login page is not working. What is the use? I mean, there is no need of login again, right? Let it be down. They'll fix it by the time we log out. So like that, microservice architecture will work. So this classic load balancer is suitable for microservice architecture, but you have to create like a load balancer for each and every service. Imagine like a cluster load balancer, load balancer service type in Kubernetes. Why we used Nginx? Why we used Ingress? Because with one Ingress we can route the traffic to all the services, because it can have the rules and everything, right? Similar way here also, classic load balancer, if you're using, let's say you have microservice architecture and you want to use classic load balancer. So in microservice architecture applications, I mean the services are running independently, means they have to independently, let's say login page, it's running 5 containers or 5 service servers, let's say, imagine, and it needs a load balancer to handle the load. Let's say payment page, payment gateway application service, that is running separately, it has 10 servers, and it needs a load balancer. Like that, each and every service needs a separate load balancer. So now we have to create that many classic load balancers for applications. It's not a good practice. Why to create that many load balancers? I want a solution, just like Kubernetes Ingress. I want to create only one load balancer, only one, and I want to distribute the traffic to all the services, no matter how many services are there in microservices architecture. I want to distribute all the what is that? Distribute all the traffic to all the services using one load balancer, only one. That's where the new things come, called application load balancer. Yeah, application load balancer. Application load balancer, it works on HTTP and HTTPS protocols, so good for your web applications. Of course, you can set up HTTPS also. As of now, not possible. So before creating application load balancer, let's cancel it. Same options you will see: name, internet facing, network, blah blah blah, security group, listener. See, all will be same, except one change will be there, that we'll see now. See, I told you just now, right? With one application load balancer, we can route the traffic to all the services, no matter how many services are there. But how does we manage the services? Means by using something called target groups. Target group are nothing but like, let's say we have multiple applications, multiple servers. Their servers are running for multiple applications. Target group is like a group, means obviously group of resources. So in our case, easy to instances. My payment my payment service have one server. So I will I'll create the group. I'll add that server to that group. My login service have two servers. I'll create a group for that, and I'll add the login servers into the group. Why I need to add it is, in the application load balancer, we have something called path based routings and host based routings. You have seen this in Kubernetes Ingress. Path based routing means based on the path, let's say slash A go to one service, slash B go to one service, like that. And host based routing, slash host, I mean slash not slash host, abc.com go to login, xyz.com go to payment, like that. So these kind of options are there in same thing. Whatever you see in Ingress, same thing is available in application load balancer also. So there we deploy separate services, right? Services have multiple pods, I mean internally. Similarly here we create target groups for each and every service. We have to create. Let's say you created only one target group and you have all your services servers in the target group. It's confusing. One time if you open, it will go to login page. One time if you open, it will go to some other page. You need to make it separate. That's why you create target groups separately for that. So what is the target type? Instance, IP address, lambda function, application load balancer. So for us, instances for now. Choose instances. Target name, maybe let's say app1. App1 is my target. So protocol HTTP, yes, obviously. Address IPv4. This is the network, same network. Health checks, you have to give the health check, same thing. Index.html, same health check. There is no change. 8 seconds. Unhealthy 2. Timeout maybe 10. Interval 10 seconds is fine. 30 is too much. Success code 200. It should usually when it is success, obviously it will get 200 success code. So by default, so if it is 200 success code, it means it's healthy. If it is not 200 success code, it is not healthy. You can give ranges like 200 to 500 as an example. Don't give like this. So anything between 200 to 500, it is considered as success. But 500 is an error. 400 is also an error. 200 to 299 maximum. Anything between 200 to 299 is success. Like that you can give. But we don't want it. That's it. So same thing. Just first thing we choose what type of target you want to add. Instances. And what is the target name, protocol, and of course the network, and finally health check. Next, create. Sorry. Time. What? The health time was smaller than interval. Where is the interval? Timeout maybe 8 I'll give. Healthy threshold, sorry. Healthy threshold I gave it. So no, my bad. Added. What server you want to add, right? Apps 1 server you will add. It's added, see. Create target group. So now we have target group with one server. Obviously it won't do the health check now. The target group we have added health checks, right? But it won't do it because once we added this target group to the load balancer, then it will do the health check. Earlier in classic what we did, we added the servers directly because it's a pretty direct approach. But now in application load balancer, I told you it has a feature to route the traffic to all multiple services, right? With one load balancer. So directly you can't add the servers. You have to add the target groups. That's why we're creating target groups for each and every service, and the target groups will be added based on the our roles in load balancer. So one target group is ready. Let's create one more target group. Instances, obviously app2 is my thing. Protocol float, blah blah blah. These are all fine. All these things. So I'm just skipping those. HTML healthy threshold 5. No, keep it 2. Minimum is 2. Healthy threshold, see here. Unhealthy 2. Timeout 8 maybe. Interval 10 is fine. Next, add your app2 server. This is app2 server. Add it. Create target group. It's added. Still it will be unused, obviously. I told you, right? The servers are still not unused because once you add to load balancer only, it will come. So now go to load balancer, create load balancer, application, blah blah blah. Load balancer name, ALB, application load balancer, simply. I'm just giving name. Internet facing, network same. This network also same. Select the availability zones, obviously. Select all of them as I told you. Security group default, okay. Listener ports 80, obviously load balancer. Now here a new thing. See here, earlier what happened? Listener ports at the load balancer level we gave 80 something HTTP, and instance port also we gave instance port at instance level. But now we don't have instances, right? We have target groups. Now what we have to do is we have to define the routing. By default, if I hit the load balancer, what should happen? The traffic should go to which target group? App1 target group, like this. Got it? We'll change the listener rules later, no worries. But for now, what happens is if you open, it should go to, it will go to app1 target group. App1 target group means our server is there inside app1. What is the content? This is server 1, something will come, the application will open. Now this all leave it, we don't need it for now. Summary, let's create. So now it will take some time. Now let's go to target groups. The server health status will change. Now it's added to target group, right? The app1, where is app1? Go to health checks. Sorry, targets. See, initial, it means it started health checks, because only after adding to load balancer it will start health check. Now let's go to this one, app2. It's still unused because we haven't added this yet. We'll add this, don't worry. But for now, let's make it running, I mean this app1, because by default we selected if someone hit load balancer URL, by default there will be a demo URL, right? Sorry, DNS name. If someone hit that, it should open the app1, I mean whatever the content is in app1. So let's wait. We have to wait for 30 seconds. Let's wait. Come on. Still taking. Okay, let's wait. No worries. Why the hell it's taking? Still is registering. See, target registration is in progress. Still it's taking time. Let's wait. No worries, let's wait. We have time. Come on. Wait. Yeah, now it's became healthy. Now you access with your, what the load balancer URL. By default, server 1 will come. Oh, obviously. Uh, Wait, I had to okay, let it load. Let it see. Server 1. Now we can configure our rules. Now imagine that this server 1 is a login page. I can change the content if you want. So this is the login page. Now if I told you, right, load balancer have options like path based routings and host based routings. It means one load balancer only, different target groups, that's it. I'll add simply change my listener rules and routing. So if I try to access like /a or /b, whatever, or /payment, let's say, it will go to server 2, my app 2. So like that, just like ingress in Kubernetes. Let's click on this one. This is your listener, right? Rules. Now go to add rule here. Add rule. Oh, okay, we need to define a name. New rule, something. This is new. Okay. Conditions. You have to add a condition. Add condition. If, sorry, path. Sorry, choose condition and give path. If it is / maybe app 2. Sorry, it's not one value. If it is /app2, confirm. If the path is /app2, what should happen? It should forward to target group. Which target group? App2. App1 is already there, so app2. So now, oh sorry, one is allocated. Sorry. Now next, priority. Okay, let's keep it 1. It's not there earlier, sorry. Now what I just did is I added a rule, new rule. What is the rule is, if in the URL, if you any user access with /app2, go to app2 target group, send the forward the request to app2. If it is no URL, it will go to by default app1. So let's create. Now go to our app2 target group. Obviously the health check will start. Let's wait. See, because now the load balancer is using this one. So it's like classic means we had to have individual load balancer for each and every service if it is a monolithic application. If it is a if it is a microservice application, my bad, sorry. If it is a monolithic means a single application, classic will be absolutely good, no issues. But it's a microservice application, we have individual services, we cannot create, or we can create, but we don't want to create multiple load balancers for each and every service. So that's why what we usually do, we chosen for application load balancer, where it can handle multiple routings concepts called path based routing and host based routing, which is useful for us. With one load balancer we can route the traffic to all the services. So all we have to do is create a target groups, add your servers, whatever the servers are there, and what you do, once you add the servers, once you add the servers, configure the load balancer routing, add the condition, add the rule, the condition, if URL slash whatever it is, go forward the traffic to this target group. Of course it will fail, but that's okay, but it's trying to go to the second server, because we have to configure our Nginx a little to handle these kind of things. Okay, let me handle that. That's at Nginx level, not at load balancer, don't worry, because Nginx by default will respond to slash app2 means it will think okay, it's different. So but we have to configure a little Nginx. Let's wait. But load balancer configuration is working fine. Blah blah blah. Yes, let me just make it big. Okay, it is here. Okay, yeah, let's include something. I think you know this, I'm just having the location. I'm just forwarding the request, that's it. Let's see, let's save it. Let's see the syntax first. Okay, we can do that in multiple ways, but I'm just trying. So first let's access with our IP. Where is this? If that should work. App2, come on. Server 2. App2 still failing. Is it app2 or apps2? Let me check again. App2. Proxy pass is not working. Let's try. My bad, wait. All good. But yeah, but you can observe, right? Yeah, now it should work. I'll make it apps, because Nginx, sorry, load balancer is expecting apps2, not app2. I'm just making it yes. Restart Nginx. Yes. App2 it should fail, obviously. Apps2 should work. Yes, now go to load balancer, apps 2. Still it is not working. What configuration? I mean, I'm telling you, right, this is not load balancer issue, this is application issue. So don't worry. I need to configure Nginx something in order to access this. Apps 2. What to change? That's okay. We are wasting time in Nginx. That's fine. But you got my point, right? It is going to Nginx server only, the app 2 only. But we have to do few configuration in order to access it. But you got my point, right? How it will work. I mean, how it will forward it. Or let's try to change the rule a little. Maybe we'll see. Edit rule. Blah blah blah. Blah blah apps 2. Edit. Let's add few more conditions. If it is slash apps 2, sorry, app 2 it is. I'm an idiot. My bad, my bad. Apps 2. Let's add it apps 2. Let's remove this one. Confirm. Next, blah blah blah. Forward to target group. Yes, it's already all there. Yes, yes. Save changes. Now it should work, I believe. Let's wait. Apps slash apps 2. Okay. Let's see. Still it is, but Nginx you can see here. It is going to Nginx. But it's the Nginx error I have to change. Come on dude, why it's not working? It's okay, don't mind this Nginx. You can try the same Nginx rule. Maybe let's try this. Let's give slash star like this. Apps slash 2. Yes. No. Again we have to do some configuration in Nginx. But yeah, that's fine. Leave Nginx. It's fine. But you can see at least it's going to the server. But configuration is wrong. Obviously, I had to make some changes in Nginx. But you got my point, right? What I'm trying to say. How the routing works. How one load balancer can route the traffic to multiple services using path-based hostings. Is it clear? That's how generally use most of the people. I mean, uses application load balancer for their applications. For their tools. Because of this advantage, one load balancer only, we can route the traffic to all the services. That's the main advantage, and that's why people use what is it, application load balancer. So let's sorry, not listener. Let's delete the load balancer now. Is it clear? I mean, sorry, before deleting, is it clear? Load balancer, is it clear about this one, application load balancer? There is one more thing, that's why. Any doubts so far? Anything? Okay, I take it as no then. So let's go to another load balancer. There is one more called network load balancer. Let's create it. This also load balancer works similar thing, except the only difference is if you observe here, application load balancer works on HTTPS protocols. So in the OSI layer, OSI models, it's layer 7. So don't ask me what is OSI layer. It's layer 7. It works with HTTPS. But if you see here, this classic, a network load balancer, it does not have HTTPS, because it does not know it doesn't know HTTP HTTPS traffic, but it's also load balancer, but it's not suitable for our regular HTTP applications. We can, these HTTP applications, right? We cannot use network load balancer for HTTP applications. See, because it does not know HTTP protocol at all. It does not know anything about the HTTP. It knows only TCP, UDP, TLS. What? But why we you need this load balancer if it is not supporting HTTP and HTTPS? Because it will be better suitable for applications like databases usually works on TCP protocol, so we can use that, like cache mechanisms we can able to use that. So for those kind of scenarios we can use network load balancer, but the creation is same, there won't be any change. See, NLB I'm just creating network load balancer, internet facing, blah blah blah, net, select all these things, select security group, same thing, select that our app. See, but if you see, we have target group, right? Correct. Why it's not showing? Because the target group is HTTP target group, it won't show here. So if you have any cache mechanism databases like this, you can keep in backend, in the backend for this load balancer class, the network load balancer, then simply create, you can able to use that. I can't show you, but you try to practice it. So is it clear? And there is one more load balancer called gateway load balancer. Honestly, I no idea what is it. As of now I haven't used, I haven't tried, but maybe in future classes we'll see. But as of now, these three load balancers: classic, which is old generation, application, and network. Let's try our target group. Let's try network. Maybe I have to. Come on, man. Yeah, actions. You cannot edit it. You have to delete it. Okay, let's delete this also. Delete, yes. Create a target group, instances. What is the name? App, some maybe new app 1. Protocol, here you have to select TCP. See, uses with a network load balancer, because HTTP it won't work. TCP does, sorry, network load balancer does not do this protocol. So we chosen TCP 80 port. Let's keep it. Protocol also TCP here. See, traffic port. It'll now there is no path, because HTTP only have path. TCP no path. TCP usually talked with port number based on the port, whatever port we have. Traffic port 80. Remaining maybe keep it 10. Timeout 8. L3 L2 is fine. Next, add your server, maybe app 1 port 80. Okay, create. Obviously it will be unused, as I told you. First let's create network NLB, network load balancer. It means select everything, every load balancer. So target group C. Now because it's TCP, go blah 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 blah. Next, create load balancer. Wait. Let's go to target group details, refresh, it will be initial. Yeah, let's wait. Sorry. Come on. Wait. Wait. Come on, 1 minute, sorry. Okay. Come on, it is taking too much time. But yeah, we cannot do anything except waiting. Okay. Yeah, finally. Let's see. Let's access. Where is it? Okay, this is the one. Let's access here. Let's see if it is works. It should work. This is server 1. I mean, sorry, that's ours. Obviously, HTTPS will be there. I'll remove it. Yeah, I remove HTTPS. Let's wait. This is removed. I can remove this. Let's open here. It's working. How? I told it works only with TCP protocol, but HTTP how it is working? Because the application behind the NLB, I mean the network load balancer, is a HTTP application, right? Nginx is an HTTP application. That's why it is working. So you can route the traffic like this also. In interview, people ask, what is the difference between application load balancer and network load balancer? The first difference is the protocols. Application supports HTTPS and HTTP, NLB supports TCP, UDP. So NLB does not know HTTP applications, but if you have HTTP applications behind NLB, it will try to access, it will try to work, I mean. Next, there is one more difference. Let's go to our rule listener. Sorry, not this. This is our new rule, right? Edit listener, obviously. If you see, there is no listener configuration here. Let's cancel again. Let me come back. Go to, sorry. Wait. See, there is no editing the listener configuration. Actions, edit listener obviously there, but there are no rules. Observe here, there are no rules. Why? Because application load balancer works in the routings, called the routing types like path based routings and host based routings. But network load balancer does not work on that. Network load balancer works on port based routings. Port based routings. So it does not know path based routings and host based routings. It works on port based routing. So if you have to add multiple listeners here. One listener is already using what is the port 80. Now you will be using 8080. Let's, in our case, let's use 8080. I'm just creating a new listener with 8080 port forward to, obviously I have to create a target group. I forgot to create target group, my bad. Let's create a target group instance blah blah blah, new app to HTTP port, no, it should be TCP, correct, right? HTTP, no, it should be TCP, correct? LG threshold 2, timeout maybe 10 seconds interval, sorry, timeout 5 I'll give here. Let's next add your server app to include create. Now go to here, refresh, have to add it. Now we have two listeners. One is different, based on the ports numbers, because application load balancer works on rules, listener rules. Listener rules means, wow, this sorry, what are those? Listener rules means like this one, path based routings and host based routings. But network load balancer works on port based routings. So you have to add new, you cannot add a new rule, but you have to add a new listener with a different port and add your target group here like this. So is it clear? That's the differences. Let me tell you again what are the differences. General question, this is a very generic question actually, people ask, what is the difference between network load balancer and application load balancer? Network load balancer works, let's keep it, application load balancer works in HTTP and HTTPS protocols, and network layer 7, it's in the OSA model, it's layer 7, and application load balancer, network load balancer works on layer 4 protocol, which is TCP and UDP protocols. Application is layer 7, HTTP, HTTPS, network is layer 4, TCP, UDP protocols. And another thing is network application load balancer have path based routings and host based routings, where we can route the traffic based on the path /a/b whatever / like this, and host also abc.com, xyz.com like this. But network load balancer works on port based mechanism, port based. So you can't have new rules, but you have to create new listener configuration with a new port, different port, and route your traffic to the new target group. That's the difference. So is it clear? And of course the capacity is different actually, because network load balancer, it's not HTTP anymore, it's a TCP, right? It can handle millions of requests compared to what is that application load balancer. Obviously I have to access with port number because the port is changed. The port is different, right? 80 is for another target group. We have new listener configuration with 8080, which is for another application, server 2. Let's wait. It will take some time, obviously. Let's wait. For the first time, it will take some time to establish the connection. Once it is established, it will be normal. See, server 2. 8080 server 2. 80 server 1. See, like that. That's how NLB works. NLB usually works with the TCP UDP protocols. It will be very good for services which uses TCP UDP protocols, mainly databases like these. And of course you can use it for HTTP applications also, but make sure your application is running in HTTP and you have to set up separate rules based on the port numbers. But I don't like to use port numbers, right? In production I can't use port numbers 80, 81, 82, something like that. So I'll be using application load balancer for that. I'm just telling an example. So yeah, that's about the load balancers concept. Hope you understand. Any doubts so far?
Once practice.
Okay. Tomorrow there won't be any class. I have another appointments. Sunday we'll meet again morning, same. Oh yeah, same time, 7 o'clock. Please be available by 7, not 7:10. So at least for 7:05. Okay. I know, because nowadays AWS, I'm pretty sure AWS will take 1.5 hour every day, because I can't stop in between, but because you don't understand if I stop it. So try to make sure join by 7:05. We'll try to finish early little. All right. So all right,
Yeah,
then
no.
we'll
Okay.
meet tomorrow. Sorry, Sunday. Bye all. Happy Friday. Happy weekend.